Welcome back. So let's look at this question. Is a geometric question. We need to solve or find all the missing angles that is given to you here. To do this, what we're going to do to make it simpler is that we're going to basically find all angles, including the ones that they are not asking us to find, but it will help us to find the other angles. All right, let's start with angle 2 because the easiest angle to find is angle 2 right now based on the given information. So a couple of things you have to remember. Number one is that you have what is called as this tangent line. So this line right here that you see is the tangent line, right? And this line right here, which is the radius coming through, that's the radius. And the tangent and the radius or the line that goes through the center, the radius that goes through the center hits the tangent line. And at the point of tangency, they create this angle called a 90-degree angle. So we know based on that theorem, that's a 90-degree angle. This is, we can call it tangent rad theorem. Okay, so that's number one. Now let's look at what this angle is right here. And that angle is very simply put, we have angle 35 plus 90, that's 100, and so let's do the 90 plus 35. Whatever we get, we have to subtract that away from 180. Okay, so that is 125 from 180. That will end up being 125. That would be 55 degrees. All right. Okay, so what I did actually, remember that this is not angle, this value right here that we just got is not actually angle 3. This is this angle here, which is on the side of angle 4, which is supplementary to angle 4, and I wrote it up here for you. And the reason is angle in a triangle equal to 180. So to clean this up, let's erase that. Okay, very nice. Now that we have this angle 55, what is angle 4? Well, angle 4 and angle 55, they are supplementary. That means they add up to 180. So angle 4 in here can easily go back and say, here's what angle 4 is. Angle 4 is 180 minus 55 degrees, which is equal to 125 degrees. So that's angle 4. And that is, angles are supplementary on a line. That's angle 4. Excellent. So we got this angle right here now. That's 125. Very good. Now we have 125. So now what is this angle there? So let's go back. Let's look at this angle right there, the yellow, if you can see that. Actually, let's change the color, that angle. Well, that's opposite of angle 55. So this is 55 because that's vertically opposite angle. Okay. Once we have that angle 55, angle 1 and angle 5, they are equal to each other. So why is it that angle 1 and 5 are equal to each other? Because this triangle that you see, that triangle is an isosceles triangle. Therefore, the base two angles must be equal to each other. And so what we get is whatever is left of 180 degrees. So let's do 180 minus 55 degrees. And that would be 125. But because of these two angles are equal to each other, we have angle 1 equals to angle 5. That means 125 degrees divided by 2, that would be 62.5 degrees. So each of these two angles are 62.5 degrees. So let's write that down, 62.5 degrees. and 62.5 degrees. And that would give us 125 together. Okay, and the reason for that is that A, B, and C is an isosceles triangle. Excellent. All right, the only one that is left is angle 3, and angle 3 is, we are going to use the tangent and chord theorem, and the tangent-chord theorem says angles between the tangent to a circle and a chord, which is angle 3 right here, is equal to opposite inscribed angle to that chord. So that's the chord right here, AB. In this case, let's call it D. My apologies for that. Okay, so AD, this is the chord we have. This is the chord. AD is the chord. The angle 3 is the angle between the tangent line to that chord, is equal to the opposite inscribed angle to that chord. And the opposite inscribed angle to that chord is angle 1. So therefore, angle 3 is also 62.5 degrees. And the answer is, the reason for that is the Tangent-Chord Theorem. So we got all the angles and more for this question. I hope you found this useful. Come back again for more exploration of mathematics and concepts in geometry and trigonometry. Okay, see you soon.